Good morning, children. Today we'll discuss about the first chapter, that is matter in our surrounding. Matter in our surrounding. Okay. So, what is the definition of matter? What do you mean by matter? I think you studied in lower classes also. Matter is anything which occupies space and has mass. So, matter is anything which occupies space and has mass is nothing but a matter. We call it as a matter. We call it as a matter. How matter is been classified in olden days? Early Indian philosophers classified matter in the form of five basic elements as air, earth, fire, sky, and water, called Panchatattva. They used to call it as a Panchatattva. They used to call it as a Panchatattva. On the basis of physical state, matter is classified as solids, liquids, and gases. So in the present chapter we'll discuss about this only, that is on the basis of physical state of matter. In the second chapter we will discuss about on the basis of chemical composition. Matter is classified as pure substances and mixtures. We classify it into pure substances and mixtures. So pure substances may be elements or compounds. Again, you can categorize pure substances into elements and compounds. Mixtures may be homogeneous mixtures or heterogeneous mixtures. There are two types. One is a homogeneous, and the second one is a heterogeneous mixtures. We'll discuss about that in the later class. So physical nature of matter. Physical nature of matter. Matter is made up of particles. The first and foremost important point, matter is made up of particles. So children, I told you about this. Matter is made up of fine or small or tiny particles. Second point, particles of matter are always very tiny. So usually we call it as first one is they made up of particles. Second one is the particles of matter are always very tiny, means very small. The particles of matter have space between them. Okay, in case of liquid and gas, I think you will be knowing about, there will be a space between the what we call it as particles. Particles of matter have space between them. Particles of matter are continuously moving. Okay, the particles of matter are always continuously moving. Not in moving means it is a kinetic energy. Okay, moving. Particles of matter are always moving. Especially in case of gases, you can see a rapid movement. Okay, that is why particles of matter are continuously moving. So this is the physical nature of matter. Fourth one, the particles of matter attract each other. So you know this, there will be a force of attraction between the particles of matter. That is why the particles of matter attract each other. Particles of matter attract each other. Okay, matter is made up of particles. First physical nature of matter, that is the matter is made up of particles. So we'll discuss one activity so that we will come to a conclusion about matter is made up of particles. So what activity we can do is, take some water in a beaker and note its level. Okay, what you are supposed to do, take some water in a beaker and note its level first. With the help of marker you note it, then dissolve some salt or sugar in it with the help of glass rod. Make use of a glass rod, so dissolve it properly. Okay, so the salt dissolves in the water, but the level of water does not change. This is a very important. The water level will not change, means it will not decrease or it will not increase. This is because the particles of water get into the space between the particles of water. This shows that matter is made up of particles. So children, I told you that in between the particles there will be a space. We call it as a inter particle space. In that space this sugar or salt will dissolve. Okay, that will take a place of this, that will take a this space, means sugar or salt whatever you dissolve, that will take a this space, and that is why the level of water remains same. So in the first beaker water, to that water we have added sugar or salt, then we have dissolved it. But in the first beaker only, while adding sugar only, we have marked the what we call it as level. In the level of water in the beaker it will be same, and at the end also, after dissolving sugar also, the level of water remains same. This shows that matter is made up of particles. Matter is made up of particles. This is one of the important activity usually they will ask in the exams, that is matter is made up of particles. Okay, they may ask give reason, like that they may ask questions also. Second point, second physical nature of matter, that is particles of matter are very tiny. Okay, this is very very important. Tiny means small. Okay, how? So we can understand this activity by taking help of a familiar example, that is a potassium permanganate. So I told you about this potassium permanganate. Okay, we will take the potassium permanganate. How this activity is done: dissolve 2 to 3 crystals of potassium permanganate in 100 ml of water in a beaker. So what you are supposed to do, you make use of a beaker. In that, dissolve 2 to 3 crystals of potassium permanganate in 100 ml. First only you take 100 ml water, to that you add 2 to 3 crystals of potassium. Crystals means that is just like a salt. Crystals will be there. Add just 2 to 3 crystals, not spoon, crystals. Okay, in a beaker, take 10 ml of this solution and dissolve in 100 ml of water. What we are supposed to take from the first beaker, see, you can notice there, you can take 10 ml from there, and then you again add it to the another beaker. Okay, solution, dissolve in 100 ml of water. To that you again add water, again you dilute it. What happens? So the color of first beaker and second beaker, you can find changes. Again from the second beaker you take 10 ml, again you add it to the another 100 ml beaker containing water. Okay, just go on repeating it 5 to 6 times. Okay, you are supposed to repeat it for 5 to 6 times. This shows that few crystals of potassium permanganate can color a large volume of water, because there are millions of tiny particles in each crystal. So even if you have diluted 5 to 6 times also, still you can find the color. Okay, so in the beginning you can see almost purple color. Okay, violet or purple color. Slowly the color fades. Okay, and it is going to be becomes pale pink. Okay, at finally it is very very light pale pink, but still you can see the what we call it as changes even after 5 to 6 times also, which means that small tiny particle is enough, okay, to give color. So this shows that particles of matter are very very tiny. Okay, in the beginning only we have taken just 2 to 3 crystals, not more than that. But in that 2 to 3 crystals, at the last beaker, when you will check it out, so you can find the color. It is not a colorless, it is a colored only, pale, light pale pink. This is due to the particles of matter are very very tiny. You cannot see it with the naked eyes, but you can see color shows that particles of that particular potassium permanganate is persisting. So this is a second B, that is the particles of matter are very very tiny. Third one, C, particles of matter have space between them. This is a very very important again activity. Okay, the particles of matter have space between them. Activity, you can understand this with the activity. Take some water in a beaker and note its level. Dissolve some salt or sugar in it with the help of a glass rod. The salt dissolves in the water, but the level of water does not change. This is because the particles of salts get into the space between the particles of water. Already you studied this activity, same activity. you can explain it for C also, and even for I think A, that is a matter is made up of particles. For the same for two uh, nature, you can use the same example. In first one you can talk about particles. In the C you can talk about space between them. Because of that only the level of water remains same. Then D will go for D, that is the particles of matter are continuously moving. So children, you can see, so take some water in a beaker and put a drop of blue or red ink slowly along the sides of the beaker. So this I think you can do it. Just take a drop of ink and pour it into the what beaker containing water. Leave it undisturbed for a few hours. You are supposed to leave it for a you leave it undisturbed for a few hours. The ink spreads evenly throughout the water due to the movement of particles of water and the ink. So in a transparent beaker you can do this experiment, that particles of ink which is moving, okay, constantly, which is moving in the water, because the particles are always moving. The intermixing of two or more different types of matter on their own is called diffusion. So we call it as a diffusion. Constant, continuously moving particles of matter are continuously moving. So because of a diffusion. So a familiar example that you people you will be knowing. Okay, if you use agarbatti, the smell of agarbatti will reach far distance to some extent. The reason, because of the diffusion you can smell it properly. Because of diffusion, that agarbatti smell will diffuse faster in the air and it will reach what we call it as to some distance. That is why we experience the smell. So that is what particles are continuously moving, not in a stationary mode. They are always in the continuously moving. Particles of matter attract each other. So this is another activity. You can notice it very clearly. Take an iron nail, a piece of chalk and rubber band. Try Try breaking them by hammering, cutting or stretching. It is more easier to break the chalk, less easier to break the rubber band and difficult to break iron nail. So you can take three things, that is one chalk and then iron nail and rubber. It is very easy to break chalk, okay. Then it is very difficult to little difficult to break rubber band, but very difficult to break iron nail, okay. Why it is so? Okay, since both all the three are solid only, but you can find there is a difference in what we call it as, when you hammer it, it will not break easily. Okay, what might be the reason? This is because of the particles in the iron nail are held together with a greater force than in the rubber band or chalk. Okay, because of that only it is very difficult to break what we call it as iron nail. Rubber band and chalk you can break it very clearly, okay, but it is very difficult to break what iron nail. Okay, so that is particles of matter attract each other. Particles of matter attract each other. So children, next we'll go for the states of matter. Side heading, very very important concept which we have studied in lower classes also, that is the states of matter. Matter exists in three different states. They are solids, liquids and gases. Later we'll study about another two, Bose-Einstein and plasma. First we'll take the first one, that is properties of solids. We'll study about solids, liquids and gases. First one, solids. What are the properties of solids? Solids have definite shapes and fixed volume. So you studied about this, okay. Because of this definite shape and fixed volume, you can say the shape of a solid: hexagonal, trigonal, square. Like that you are going to explain it, because solids have definite shapes and fixed volume. the space between the particles is minimum. Okay, very very less. Between the two particles you can experience a little what space. That is why they used to say that the space between the particles is minimum. In some books they will give it as the space between the particles is negligible, like that they will give, because it is very less. The force of attraction between the particles is maximum. Okay, just now I gave you example of iron nail. Their force of attraction is more. That is why it is very difficult to break. Force of attraction between the particles is maximum in solids. Then the moment of the particles is minimum. Okay, since force of attraction is more, then you can expect the moment of particles will be minimum only. It is minimum because force of attraction maximum. If it is a maximum, then the moment of a particles is definitely minimum. They are least compressible. You cannot compress it. If you apply more pressure, what happens? It will break. Okay, that is why they used to say it is least compressible. It is very it is not compressible like that of a gas. I think in gas you can fill n number of gaseous molecules in a cylinder. It is a highly compressible, but this is a least compressible one. So if you apply more pressure on the chalk, it will be made into fine powder, because it is not a compressible. Solids are not compressible. The rate of diffusion is least, very very least. So the rate of diffusion is going to be very very least. So that is why if you cut fruits and all, the smell can be experienced only means only a few meters, not very far, because the solid one it is. Okay, it will not spread so easily. But in case of liquids, you can see, you can experience the little far distance, but in gases very far distance also you can experience it. That is why the rate of diffusion is very very least in case of solids. Next comes properties of liquids. Properties of liquids. Liquids have no definite shape but have fixed volume. This is very important. They do not have definite shape but have fixed volume. In competitive exams I have seen this. In Olympiad exams they will give like this only. Okay, liquids have no definite shape but have fixed volume, like this one option. Liquids have no definite shape and no fixed volume, like that. Okay, both A and B, none of these, like that they will give. So children, liquids have no definite shape. It will take a shape in which you in what container you are going to add. If you add into the conical flask, it take the shape of conical flask. If you add into the beaker, it will take a shape of a beaker. But have a fixed volume. That is why we used to say 1 liter, 2 liter, 3 liter, because it is a fixed volume. Then and it is very difficult to tell about the shape, like solids, like hexagonal, like that, what we say. No, it is very difficult to say it with the what liquids. The space between the particles is intermediate. The space between the particles is intermediate, means between solids and liquid. Okay, sorry, solids and gases. In gases you can see lot of spaces, but in liquids there will be intermediate spaces. Okay, not like that of a solid, not like that of a gas, there will be a space. Then the force of attraction between the particles is also intermediate. Intermediate means between solid and gases. Then moment of the particles is also intermediate. Moment of the particles is also, you can say, intermediate. They are less compressible. Okay, so it is also less compressible. In a bucket, if it is filled with the water, if you apply pressure, the water will come out. So we can say it is also not compressible, it is a less compressible. Okay, then the rate of diffusion is more than solids. You can compare it with the solids. There the rate of diffusion is more than solids. Do not compare it with the gases. Okay, the gases one is the topmost. Okay, so the rate of diffusion is more than solids. Compared to solids, it is more. Okay. Then properties of gases. Properties of gases. The third one, properties of gases. Gases have no definite shape or fixed volume. Gases occupy whole space of the container. Okay, since you cannot see the gaseous molecules, but the thing is it is not having any definite shape or fixed volume. It occupies the entire container. If it is stored in a container, I think you will be knowing about LPG gas. On the LPG gas they used to write it as a 16.1 kg, 14.2 kg, like that, net weight. Okay, so means that much of gaseous molecules are being compressed in that cylinder. Okay, so n number of molecules are being uh, compressed in the cylinder. The cylinder shape may be even elongated, cylindrical, okay, like that. Even whatever the shape, it will take the shape also. Okay, then the space between the particles is maximum. So I told you, even you can see it in the picture also, the space which is available between the gaseous molecule is always maximum. That is why they will show random movement. You cannot write it in a regular fashion. There will be a random movement of particles also there in the gaseous states of matter. The force of attraction between the particle is minimum. Okay, there is no force of attraction because a lot of space is available, and what happens, the force of attraction between the particles is going to be minimum. The moment of particles is maximum. Okay, the particles will move maximum in the, what we call it, a moment. Okay, it can move in any fashion, not in a regular fashion or regular manner. It can move in any fashion. Okay, they are most compressible. Okay, you can say highest compressibility, you can see it in the gas. That is why children, in cylinder, okay, in empty cylinder it is not that much weight, but if you take a completely filled cylinder, it is little bit heavy weight, because in that 14.1 kg or 14.2 kg of gases are being enclosed. That is why they used to write it on that net weight 14.2 kg. So it has that is why in definition of matter only you can say matter is a anything that occupies space and has a mass. So even this also has a mass. Okay, you can make use of a empty cylinder and a filled cylinder. Empty cylinder is not that much weight. Okay, but filled cylinder is going to be little bit weight. So that is how more number of gaseous molecules can be compressed. So you can see highest compressibility. Okay, the rate of diffusion is more than solids than liquids. Highest compressibility, you can see it in the gases. So this is about what we call it as states of matter. So this is about states of matter.